Let me make sure you guys, okay, can you still see that?
Yes, that's perfect.
Okay, awesome. As always, I want to give the disclaimer that I'm like not the pro. I've done this once. So I just thought it would be good for everyone maybe to talk about I can show you what I did, but we could also look at like the potential of using this in future studies. I think it's really helpful. So, disclaimer, like if something's wrong or if you want to interrupt with something, please do. But yeah, this is just a hotspot analysis, and you can do this in ArcGIS, but I am so bad at ArcGIS. So I did it in R. So the purpose of this is to mostly go through how to do this type of analysis in R. Weird. Oh, there we go. Okay, so this is using the Geddes or GI star statistic, which is basically a statistical statistic that it gives you it's a short summary. It's looking if there's clusters of your specific variable with high values or low values. So a hotspot is considered an area where you have high values of your variable, whether your variable is like incidence of a disease, or in my case, it's high values of cesarean deliveries. And cold spots are going to be areas where you have low values. So what this Geddes or GI statistic does is it's a spatial analysis, and it gives you a z-score. And that z-score is meant to represent, is there like spatial clustering of higher values of this variable, whatever your variable is. So the more positive your z-score with the lower p-value means you have like more evidence for a really strong positive core, like not positive, high value clustering, and then vice versa for low values. Um, okay, so you can run this in R, which is awesome. And the most important packages are this SF package, SFDEP, and SPDEP. And then the regular packages are kind of familiar. We use these a lot for just basic data manipulation. And then this last one, GeoBR, is awesome. I'm sure everyone who's done, I'm sure you guys are familiar with it, but this is a great package that has a lot of data related to Brazil. All right. So for preparing the data, you need like whatever variable you're studying. For my case, it's cesarean delivery percentages. So on the right, it's this 5-year average. So basically, this is the average of their cesarean deliveries over the 5 years for each municipality. So I'm not going to try and pronounce those names, but this first municipality had an average of 41.8% cesarean deliveries. And you also need spatial data. So this is like kind of the difference between a regular statistical test. So this spatial data comes from the GeoBR package, which is really nice. They have it all in there for you. They have like state level spatial data, regional level, micro regions, and municipalities. So this data is stored a little differently. And from my understanding, it's almost like a list. I think of them as like it's the coordinates, their latitude and longitude, and it's a list of the coordinates for each municipality. Does that sound right? Cool. I'm getting a
Yeah.
nod.
Mhm.
Okay. So you need that type of data as well. Oops. Sorry, I keep clicking so it goes. So the first thing you have to do is you take your like regular data frame, which is what we have here, which we're kind of used to seeing with your spatial data, and you have to convert it to an SF object. I'm not totally confident in why you have to do that. I just know it's going to tell R that you're treating this geom variable as spatial data. But does anyone want to jump in on like if you have more insight on that SF object?
Um,
Yeah,
I guess that's the extension to what you said. The final thing there is basically whenever you do any changes to that data frame, if you want to merge, if you want to summarize, etc., using other packages, it's going to lose that characteristic of spatial data. And it's always a good practice, as you said, to make sure it is in the right format. Otherwise, you're going to get a warning message and it's not going to work.
Yes, I ran into that issue because with the Brazil data, my strategy a lot of times has been to like condense it to what I need and then save it as a CSV file so I don't have to do all those steps above. But if you save this, be like your SF object as a CSV file, it won't maintain that spatial data. So that is a good word of warning. Yes, so this is,
can I jump a little bit
oh
too?
yeah.
Yeah, so an SF object is a shape file. So since we're working with spatial data, we have a geometry. That's why in the other, if you go back to the other slide, yeah, so it's a geometry, and you have a polygon because you can have like a polygon, you can have a line, you can have a dot, a point, and it has like the coordinates, but also it has the length of which area it's covering. So if you try to, if you not convert your shape file, it will treat it like it's just another information, which is not. So it's a spatial data that has information on which municipality is close to the other, with what's the size of each municipality and so forth. So the important thing here is that shape files are one of the few formats that we have to use with spatial data. So we have shapefile, we have a geodatabase that can store a lot of information about geometries. So if you try to save it as a CSV file or any other format that is not a spatial format, it will lose the shape, it will lose the geometry. So for a spatial analysis, the geometry is very important. So that's why we need to convert it.
Perfect. So helpful. Thank you guys. And I think that will come up in a second. Yeah, and the nice thing is in that SF and SF depth package, all these functions are there. So you just insert your data frame and then you just tell them it's your geom object, which just comes from there. So really super easy. The next thing you do is you're going to create a neighbors variable. So basically, my understanding is this is going to look at, for our scenario, what one of our municipalities are neighboring the others. So where they're sharing borders. So you just use this nice poly. So it's like your polygon to neighbors list. You put in your data frame and you can do a bunch of different like tests. I did the queen continuity because I just read that that's like the best one, but I'm not sure. And I think it's almost, my understanding is it's almost like Boolean logic of like true, false. Is it matching borders? Does that sound right? Natan or Joao, if you want to add.
Yeah, the queen variable is actually the most common ones is the rock and the queen, so it comes from chess.
Oh,
The rock takes if it shares a border, but a complete border.
oh, okay.
A queen will have corners and edges. Like I don't know if it's like a border, a corner, or an edge. So even if it's like a little bit, just like a point, it will consider. Because the
Perfect.
queen in chess can go every other way, and rocks go yeah, up and down and sides.
Okay,
So
that's super cool. I did not know
yeah,
that, and that's really helpful. And I think for like spatial data with municipalities where you don't have like square like this is a
yeah,
better choice because you can catch
yeah.
those municipalities that
Usually
barely.
queen is the one to go. I've never seen someone use the rock one.
Mm,
It's probably most useful if you're using like county data or
mm,
something like that. But even that, I will use queen.
okay,
So
good to know. Everything I'd read said like queen was your safest bet. So obviously don't take my word as final word, but so yeah, you create a neighbor list and then oops, this is what it gives you, the output of that. So my understanding is it basically like this list right here, these are all municipalities that are touching according to that queen criteria. So you can see like, okay, the like 9 and 16, 18, 20, and 33 are all bordering. And you're going to want this idea of like what municipalities are touching when you go back into the spatial analysis to do the GEDIS or GI. So this is basically what that output gives you. I'll just do the next thing and then we can see if anyone wants to add. But you do have to remove municipalities that don't have neighbors because that's going to mess up your analysis. So I was lucky with my data set. There were just 6 polygons with empty neighbors. And because we had over 5,500 municipal observations, we felt like that was okay just to remove those. And I was almost thinking of them as like data entry issues if they're not like matching, because every municipality should be at least like touching one, does that make sense? So then you just basically remove any that are missing if it's a small enough number. If not, you might need to go back and readjust. And then you just create your final neighbors list after you've removed your missing one. Do you guys want to add anything here on either of those slides?
just that those sixes are probably the islands that we
Oh,
have in Brazil. So that's why we don't have any neighbors.
I'm gonna make a note of that. Perfect. Okay, so yeah, context is key of why you would be missing neighbors. Okay, So the next thing you do is you create a spatial weighting variable. Again, all of these functions are just in the SF and SF-det packages. I did a binary weighting, not totally. I know there's a ton of options you can do. I think you can do like a K nearest neighbor, different things. I did binary weighting just from what I had read of other people's methods. This seemed to be their strategy when they were doing a similar analysis. So my understanding is this is gonna assign, it almost like adds a value of 0 or 1 based on if municipalities are neighboring each other. So it's like municipality 1 and municipality 2, if they're neighboring, they'll get a 1 on like the intersection at their of their row and column. Does that make sense? It's kind of tricky to explain. Anyone want to add? Sweet. Okay. The next thing you do is you calculate your spatial lag. And sorry, this is from old notes. That should say 5-year cesarean section. So what this does, again, you can just use a nice little function here, is it's going to take basically your spatial weighting, your spatial weighting, which we created up here. And then it's going to take your variable. And what it does is it's going to average. So for us, 5-year average, it's going to take all of the municipalities and average them for neighboring municipalities. Does that make sense? That's like so tricky. I feel like it's so weird to explain and grasp. Does anyone want to add for spatial lags? Sweet. Okay, so the next thing then is you can just run all of this in your test. So what I showed you before was just kind of like a breakdown step so you could see, but you can also just throw all of this into one, like basically one code chunk. So here's what I did just in like one condensed thing. So we're creating our test neighbors. We're taking our final SF subset, which we created without our empty neighbors. We're mutating, so we're creating a new column called NB, and then this is going to give us our neighbors. We're taking weights. This is going to give us our spatial weights, which we just did earlier, and we're doing it with that. And then our test lag, we're using this function, and we're just doing that before. So again, it's kind of all of these steps, but just simplified and thrown into one little function. And then you can run your actual test. So we're going to take, I just called it test hotspot. We're going to take this whole, it's kind of like a data frame that you end up with. We're going to take this data frame and we're going to create a new column called GI, and we're going to run our test. So this function right here is running the actual test to get the GEDIS or GI statistic. We're looking at our variable, which is 5-year average. This NB is like our spatial weighting, or sorry, our neighbors list. The WT is our weights. And then number of simulations is 99. So this is like a Monte Carlo simulation. I'm not a pro here at like Bayesian statistics. It just throws out a bunch of different outcomes. So it just simulates. And then we simulated it 99 times and then it said, what's the most probable outcome? Does anyone want to? That's like my intro to Monte Carlo Bayesian statistics. Anyone want to add?
It's basically it. It's probably
Okay.
the simple way to explain it, because Monte Carlo simulations are hell
Yeah.
to understand. Yeah.
The nice thing is here is you just have to put a number. So 99 is like a good one. I think a lot of people do like 499, but I like was able to really easily read and pick up what numbers people were
Yeah,
using.
usually 999 is just like
Oh,
this
cool.
standard. You cannot go wrong with this one.
Oh, awesome. Okay, and then this is my least favorite thing that happens, but our GI thing that we created in this mutate is actually a data frame itself. So then we have to unnest the GI so that we can actually pull out the statistics we're looking for. And that was the biggest nightmare for me to figure out what was happening. Okay, so then the next thing you can do is you can actually graph it, which for me makes the most sense for understanding what you're looking at. This is a lot of code. A lot of it's like really similar things of just ggplot we can skip through. But basically, this is the name of my plot. We're just going to take our test hotspots, this data frame we created with our GI unnested. And what you're going to do is we're going to select the GI, which almost is like our z-score that we talked about that you get for the GEDIS or GI star test, and our p-value after the simulations. We're going to mutate, and I created a new classification, case when. So you're kind of taking two things. For our hotspot areas, anything we're defining as hot, your z-score has to be above 1 because that's showing like clustering of high values. So for here, we're looking at greater than 0, And I made our like increasing categories, so very hot, hot, and somewhat hot based off of our p-values. So somewhat hot doesn't have as strong of a p-value, and then as we get to very hot, it has 0.01, so a really significant p-value. And then you kind of do the reverse with your cold spots. So same thing, these ones are going to be less than 0. A 0 means kind of no correlation or no clustering. It's like your neutral zone. The rest of this is just me like making my labels nicer and adding my titles and stuff and adding a color palette, so we can skip that. But the really cool thing is when you graph it, you can get something like this. So again, all the data, like all these white borders, that's our polygon data that we initially had, which is really helpful. And then this like blue, very cold, this is area, these are municipalities where we had a G statistic, oops, very cold. That was less than 0 and a really small p-value. So just to give you an idea. So we can see, okay, there's hotspot clustering of really high cesarean sections in the central west area and kind of over here in the southeast, the south, and we have cold spot values up here in the north. But one thing that I think I've already noticed when I've shown this to some people is these values are relative to each other. So some people have seen this and they're like, oh, the north has really low values of cesarean section percentages. They have really low values of cesarean section percentages compared to Brazil, if that makes sense. So just when you're interpreting it, you have to remember it's like relative to your data set and the variables you have. So yeah, again, if you're looking at county data, your variable is relative to what you're looking at, not some like global, standard. I had one question I actually wanted to ask the group, but then we could just ask some questions and see. And my basic question was, if anyone knows, I also thought it would be helpful, like if you had, like if we could adjust these zeros, so maybe very hot has like a GI score of like 0.75 or higher. Has anyone seen an analysis like that? Does that make sense?
Yeah, that was my question as well, Natalie. I didn't work with this before, but I was wondering, like, for now, you are using the p-values to consider this temperature, which sounds to me even like a magnitude, like instead of just the significance, but actually how hot they are, how like think of an odds ratio, for instance, like how many times they are hotter than the other regions around. So that was my first impression. But now that you are saying, I see that you're using the p-values there rather than the actual statistic. And to that point, I don't know if it's right or wrong. It was the same. I had the same question as you.
Sweet. This was the only
Do
type
you
of
know,
example
Natalie?
I saw.
Yeah, so basically these statistics a little bit different from the autocorrelation one, the Morans one.
Mm.
So the GI, it's like a GI star is a little bit different, and what we usually do for that to like try to prevent a little bit is that we use a false discovery rate. So for those that are not familiar with spatial analysis, a false discovery rate that happens on other statistics as well, but we use that more. I've seen it more on spatial analysis. Is we try to adjust based on the amount of observations and the volume of data on which value for p-value is really significant. So we're
Mm.
trying to avoid bias, creating a lower significant rate. So we're not going to use 95% because 95 will give us that everyone's going to be in the cluster, which is impossible. So there's a couple ways to do that. And the false discovery rate is one of them because the GI star, it's the actual value of like the Z-score, the G-score, that's fine. It just says as if it's positive or negative. So it says if it's
Mm-hmm.
hot or cold. Because it's not a Z-score,
Oh,
it's a little bit
it-
different.
it's it's only gonna give you a direction, not the
Yeah,
magnitude.
it's not a
That's-
Z-score. The G's
It's not.
value is not a Z-score. The G value is a spatial correlation type of measure. So you can use
Mm.
this one. But the thing is, the p-value, sometimes we need to change to a false discovery rate. To do that, I'm trying to remember how to put that on the code. There's a way to put that on the function. There's been a while since I last worked with that. But you can use that, and then you increase the simulations to 4 nines. So 9999, 9099,
Okay.
9999. Yeah.
Okay,
Because then it will like give more power
like
to,
right.
yeah, it will give you add another 9. So it will give more power to see more, if it have like, if it really is significant, because we're lowering the p-value. And if you only do 999, it might not test all the possibilities because we're lowering the p-value. This way that you're doing, it is correct. It's not wrong. It's actually one of the prettiest codes I've ever seen of this type of analysis. But one thing that we need to test before that price, that is the GI star doesn't give you the like an index of autocorrelation. So for that, we need to do just GI, or which I prefer is to do the autocorrelation one. So you do it Moran's one.
I do have like a global, I can't remember the exact name, just like a global spatial autocorrelation that gives you like,
Yeah, so you did the GI without the star,
yes, yes.
then that's perfect.
Perfect.
Yeah, so that's
And
one of the things that we need to do.
okay, cool. That's nice. Like, but if I wanted to see some sense of direction, like let's say, like Natalie has done this map, which is really awesome to take a look on the behavior for the country. But now I want to actually quantify how, you know, how much the correlation is or something, or compare to regions or something. Then you would do something like a spatial regression or something. My
Like
question is, if you want
yeah,
to go beyond this, like, oh, we have this pattern happening in the country, but now
yeah,
let's try to quantify it. Would then we need to go to something, to a different method to do that?
yeah. Usually we go for a different method because then it will allow us like, it's unusual to use the correlation, like the autocorrelation one, to do the regressions. But what we do is we take the prevalence rates or the incidence rates or whatever rate you're using, and then we do spatial regressions, because the spatial regression is a little bit different than the normal regressions. So because GLMs are for general linear models, and since we have a spatial correlation, it's not going to be linear, even though it's GLM. So we do some different types of modeling. One of the best ones that we use is what we call ordinary least square. So what we try to do is to approximate the distribution of the rate to a normal distribution. And then we run like a linear model. But you will see some people saying that it's not the best approach, which I tend sometimes to agree. But we do have a type of regression that is called GWR. So is the geographically weighted regression, which will take into consideration the local distribution. So what it does, it's a little bit different. It will give you a global value and a local value. So for each municipality, for each unit of analysis, it will run a regression.
Very cool. So my
Okay.
understanding is this is helpful. Like these dark red spots, the very hot is less like this is a way stronger correlation than the somewhat hot. It's just like in terms of like the strength of the relationship, it's
Yeah.
more like evidence that there is correlation. And then you would do like a geographically weighted regression to actually measure the strength.
Yeah, you're gonna actually try to understand, try to see which factors are associated to that. So, okay, I know that in this area I have a higher C-section. So these areas are where you have bigger wells, for
Cool.
example.
Okay.
So then you can compare, or also like this area is where you have the urbanization rate, it's higher. So it's just like any other regression that will consider the geographic approach, that will consider there is not just like individual level, it's something that is bigger than that, because geographic land it's different than people. Land
Yeah,
has different approaches.
that's perfect.
Okay.
So in a scenario where I have something like I want to look at the relationship of municipal income level and cesarean section delivery rates, but also take into account their spatial relationship, that's when you could run a GWR.
Yes, exactly.
Okay,
And
I
then the
have kind of a dumb,
GWR will give you like a general vision of that of, okay, so this is significant, this is not, yada yada, but also will give you like, for this municipality, this is significant, for this one is not.
cool.
Because it runs a regression for each and every municipality.
Oh,
It's a little bit of time consuming, and sometimes your computer will like complain because it is really, really hard. But it's probably one of the best approaches. And you can also do that. There's two types of GWR. That one you have like standard one, and then the other one is timely. It's geographically and timely weighted regression. So you can do spatial temporal regression, just like a mixed methods for GLM.
very
Cool.
cool. I have kind of a
It's
dumb
even,
question. I think like it seems like to make a lot of sense to do a geographically weighted regression.
yeah,
Why, like compared to just a regular regression. So if I wanted to look at cesarean section rates and municipal income, it makes the most sense to me to just do a geographically weighted regression, even though I could just do a regular regression with that. So why aren't we running more like geographically weighted regressions? Is that a dumb question? Does that make sense?
I don't know if I understood correctly, but you were asking like why we're not.
I think like, okay, I have like had 2 biostats courses, so not a
Yeah,
pro here. But we talked a lot about regressions, right? And okay, if you want to compare the relationship of 2 variables. So I want to look at the relationship of municipal income level and cesarean delivery percentage. Does having
yeah,
higher municipal income level increase the likelihood of having higher cesarean delivery percentages? So my
yeah,
first like, initial thought is like, sweet, a regression.
yeah,
So, and like probably a linear regression or something. I can't think clearly enough
yeah,
right now. But it seems to me that it makes a lot of sense to do a geographically weighted regression where you're incorporating that spatial relationship.
yeah.
So, like, my question is that all, like, to me, that seems like it would always be smarter to just also include that spatial element. Or are there times when you just don't really need to? I don't know. Does that make sense?
Yeah, it does make sense. So the first thing is that we need to understand if there's autocorrelation and how strong it is. So like if you have a GI statistics or Moran statistics that says that you don't have spatial correlation, then you don't need to do.
Oh, okay. That makes so much more sense because you're not thinking that that's a variable that's going to impact.
Yeah, the spatial is not
Cool.
impacting. But like if you go for someone that has a strong, my sister's master's thesis was with GWR
Hmm.
regression, and her Moran statistics were 0.895, something like that, right? And go up to 1. So it's like really, really clustered. It's one of the highest I've ever seen. And we did everything that we were supposed to do. So we did a linear regression, and then we went to the GWR, and it's clear how like the GWR it's better.
Mm, okay.
Like it's just way better.
Cool. So that first test gave Gabby the info she needed to know, okay, I do think spatial, like there is a spatial relationship. So I do want to include that as like as a covariate almost.
Yeah, because the GWR won't give you significance because it runs regressions for each municipality. So what we usually do is we go for a OLS approach, so it's an ordinary least square that will try to approximate to a normal distribution and try to give it like which variables are significant, and using that variables we're gonna put that into the GWR, and then we're gonna go for like, okay, this is actually impacting this and that. Some people will complain about this approach. João Ricardo is one of them, uh, saying that's probably not how how you like the best approach to that, but it's the most used. It's not wrong, but you don't need to do that. You can go straight for the GWR if you have like a strong correlation, all to a spatial correlation. So yeah, you can add like not just one variable, you can try multiple ones. So it's easier. If you want to like just one variable, I wouldn't go for a regression because that will be not useful. The regression won't just because it's just one. I would go for just a simple correlation, a Spearman correlation. But again, I don't know how trustable that would be because if it's correlated, what's the point? So we need to see where it's correlated and if there's actually some sense on that. So I would go for like a GWR and then put more variables because for C-sections, you need to see like the workforce, like females on work, females on that are house, how could I say this in English? Like they don't have they're the ones that has the final word in the house.
Oh,
Something like
head
that.
of the
House
house.
chiefs.
Yeah.
So there's some statistics that we have that is important for this type of scenarios. So I will go for GWR in your case, especially if you have like this clustered thing.
Cool. That's awesome. So that's all I had presented, unless anyone else wants to keep talking about spatial statistics.
So, actually, now it's just a question for, I know that you went to Maranhão and had a chance to present a few of the results to folks there. I wonder if they had anything to talk about the profile that they see in the Northeast, and more specifically, even though this is not Maranhão, like this island of hotspot correlation here. This is not methodological, this is like theoretical a question, but if you can, just out of curiosity.
Yes. Sorry, I'm like doing a few things. I wanted to show you something that was also interesting related to that hotspot. So we did this for 5-year time periods in each section of the study, and that hotspot gets a lot bigger, which, okay, this is the right thing. So by the end of the study,
Wait, we're still seeing the original PowerPoint.
okay, I'm gonna stop sharing and I'm gonna share again.
Sounds good.
Okay, can you see this new one of 2016 to 2021?
Yes.
Oh, phew. Okay. Yeah, that hotspot region got significantly bigger. And like
Ooh.
as each time period goes, it gets bigger and bigger. I'm gonna slaughter the state name, but when I presented this, everyone thought it had to do with Rio Grande do Norte.
Mm-hmm.
And Professor, I can't remember the main professor's name there. I think it's Antonio. Oh, he mentors Marcos. I can't remember his exact name, but he had thought that this was maybe in relation to like the petroleum growth in that area and then increasing wealth in that area. And he also
Okay.
was really interested in, he felt like he was noticing a strong correlation of where we had hotspots of cesarean sections and like agricultural booms lately in soy production. So That was like a whole space
Definitely.
I had not thought about at all, but he really felt like there
Mhm.
could be a lot of potential for looking at like the agricultural booms and its impact.
Nice. And not only like there's the state of Rio Grande do Norte there is getting hotter, but I see how places that were cold spot are now becoming insignificant more recently, at least compared to the original picture, and that they might be in a transition, right? And if in the future they might become somewhat hot or hot. I don't know. That's really interesting.
Totally. Yeah, I thought that was probably the most interesting part of the whole spatial analysis. Everything else stayed roughly similar, but
Hmm.
then this little guy popped up. And yeah, other people had also recommended doing a similar analysis, but it like separated by private healthcare facilities and public healthcare facilities. And
And
I think that has a lot of potential to be a really cool, like deeper dive.
cool, cool, really cool. Sorry for hijacking the discussion, but thanks for explaining.
No, I turned it into like, I'm going to ask Natan all of my questions time. So does anyone else
Please
have anything
do.
they want to add?
I cannot shut up about spatial analysis. It's just like I love maps.
No, when this popped up, I was like, that's the coolest thing I've ever seen. I don't know if it's right,
Yeah.
but that's awesome.
Question. Have you seen have you uh, looked about the analysis that I presented, the one that I'm making the package, the space-time cube?
I looked and I felt a little more intimidated. I have not looked as much at it, but I am totally new to spatial analysis. So this is what Joao Ricardo had sent to me and
Yeah.
Charla. So okay, but I can look into that as well.
So basically what the space-time cube does is it creates GI stars patterns for every single year in this case, and then aggregates that and say, okay, so in this point we have like a new hotspot. This is a persistent, this is a sporadic. So it
Mm,
combines both the GI star with a candle trend analysis. So it's a little bit
okay,
easier to see how the dynamics are happening.
because it's like the emerging trend analysis. Is that it's like kind of nicknamed?
Yeah, exactly that.
Cool. Okay, so
Emerging
that
hotspots.
as we're sitting here like talking about how that looks like a hot spot, you could actually see like a little more like methodologically how that hot spot's growing and stuff.
Yeah, because like if you have this difference, this is like a lot of time steps. So I have from 1996 to 2021, right? So it's like 25 years. There's going to be a lot of differences there. So I would go, and it's something that we see a lot in Brazil. Things change very quickly. So I would go for, this one is beautiful, of course. And if you stick with that, it's just like amazing chef's kiss. But I would try to do something that is spatial analysis, like spatial time analysis. So spatial time cube is one of the best because it's just what you did, but for each time step, for each year, and will give you like different patterns, and you can actually see that like, okay, so this one as hotspot, and then this not significant, and now it's cold spot.
Hmm.
And then you
Very
can
cool.
create the GWR, the timely approach of the GWR, saying, okay, I have this, and that. What's happening here?
Okay, amazing. So there's a lot of potential to do some cool
There's a
analysis.
lot of potential. You can just stick with this one, which is amazing. It's great. It really shows a lot of things. And you can also do like, if you want a deeper dive, a bigger thing, uh, you can go for this approach of space-time cube and the time geographically and timely weighted regression. Of course, it demands a little more from the computer, but it's just like one of the best things I've ever seen for spatial analysis.
Cool. I will schedule a meeting with you and Charla if that's okay, because I think that could be really
Yeah,
cool potential
definitely.
for this project. Um, yeah, this has been so helpful. And I'm like so excited about, I was like, I don't know anything about this, but I can present it because I think it's probably really applicable stuff for us studying global health and like disease and
Yeah.
everything.
One thing that is interesting about the GI star is that you can use that on points as well.
Mm,
So it's different from the more in statistics where you cannot have points. You can just have defined location, so geometry. But for GI star, I think it's GI star or just GI, you can have points. So you can understand patterns by points. And it's something that the space-time cube does as well. So we can have like from points, you can define the length of a geometry that you want, like a cover area. And then you can have like track it like, okay, so how many points I have in this? It's very useful for road traffic accidents, for instance. So I have these spots here as places where accidents happen. Are they correlated somehow? Are in the same square and the same hexagon? And what do I
weird.
have there? Like, okay, there's bars in there. There's no traffic signs. That's something that we can do as well in with the GI statistics. That is very helpful.
Very cool. Yeah, I'm like excited to dig more into this.
Okay, I'm gonna shut up now because if I keep going, I can keep going. So
Yeah, well, that's all I have. So
That's awesome, Natalie. Thank you. Um, how, so you said that you haven't worked much with ArcGIS before. Have you had any experience with the other software like QGIS or any of those? Because my question would be, how do you compare? Like, is it easier for someone that wants to start doing spatial analysis starting with R, or should they start maybe learning with some of those softwares? And I mean, this question can be for the whole group as well, if you have thoughts to share.
I can speak to my own experience, but like I think GIS was, I'm like very intro level. That was a little clunkier for me to learn. I just felt more comfortable with R, so it was easier. But I've heard that GIS is better long term. I don't know. I'm sure Natan could speak way better. But for me to just like intro into this, it was pretty smooth to run this in R.
Nice.
I would say personally that if you can start with R is better because R allows you to do way more. But if you're not prolific with R, then it's probably like it's gonna be hard. So if you don't know anything about R, or if you don't have like the knowledge of coding and stuff, it's gonna be a little bit harder. QGIS is a good one to start, but it's way simpler than the ArcGIS, for example, because it's free, it's open code, so it depends on contributions. So a lot of the statistics that we do, you can do on QGIS. You need another one, like Geoda or stuff. So if you want to learn the basics of GIS, I would suggest you, if you don't have R, go for QGIS, Geoda, and if you have the money, ArcGIS, which is like if you have the money or if you have an agreement somehow. But if you do have some knowledge in R, that is enough for you to do some like pipelines and stuff, you'll be good. Do an R because it will allow you to do more than the regular ones and it's going to be free. It's a little bit harder to do mapping on R. I hate it. It's terrible, but it allows you to do so much more. So I would go for
Awesome.
for that.
Actually, is mocking my name in the behind the scenes there, but behind just to add to the discussion there. One thing that I find kind of tricky by doing maps in R is that it takes a lot of time to plot the map, especially when like Natalie, you might have experienced it because working with the whole country, all of the municipalities, it takes a lot of time to generate the figure. And even like zooming in or saving or anything, it kind of, gets your flow kind of clunky, right? I don't know how fast or how slow the other approaches are, like using the ArcGIS, etc. But I feel like being able to see the map as you are doing the changes, it's kind of helpful because every time I decide, oh, I don't like this color. I want to change the color of the palette color for the snake bite extents or whatever. It takes a lot of time. So maybe in the future I would go to one of those softwares because it's just so boring to keep waiting.
Yeah. I would say that that's one of the reasons that I have an ArcGIS license, because on R it's sometimes terrible to work with that. I just want to change the color, and it's gonna take like half an hour, depending on the type of map. I was doing this world map, so we have all the countries, and it's huge. So I said no, I'm going for ArcGIS. QGIS is a little bit like quicker than ArcGIS. ArcGIS can be sometimes consuming, but it's there because it has more ways for you to deal with how to you visualize the data. So one of the things that I really like about ArcGIS that you cannot do on QGIS is that you can do bivariate distribution. So you can plot two variates at a time at the same time on a map, which is really, really interesting. So you can see, like, for instance, you can use two different time steps. So I have this one prior to some politics and this one after the politics. And then I can plot and see then if where it's the same pattern, if it's different somehow, because it gives you like a grid of 2 versus 2, 3 versus 3, or 4 versus 4. And it allows you to see like different patterns of that. It's really interesting. You can then do that on R as well, but like I said, it's time consuming. Sometimes I just want to change the color. But it's very useful, especially if you want to like use poverty index or like some race or ethnics distribution in space. That's also helpful.
Awesome. Great.
Great. So I'm gonna finish this one. I want to say thank you so much, Natalie, for presenting that. It was amazing. It was really, really nice. And it's a really good job. A really nice work. That was really amazing. I'm really looking forward to your thesis because it's like really, really nice. Thank you everyone for engaging today, for participating. I just want to confirm that we have someone scheduled for next meeting. Lei is going to be presenting the GLM template for Poisson models, which is also really nice. And then we're going to run a little bit shorter today, so it's going to be 4 minutes for you to enjoy in your lives. All right, thank you so much, everyone, for participating and engaging. See you next week.
Thank you. Bye-bye.
See you. Thank you, Natalie.
Bye-bye.